All right, on to our next topic for the day. We are going to be talking about planets and their orbits. So in the last video, I talked about how all things that orbit are going to orbit in slightly imperfect circles. And the way that that's actually going to look is something like this. So that's just an example of an elliptical orbit. And eccentricity is just going to tell us how elliptical that is. And it's a number that you can actually calculate with other numbers. So there's a formula to do this, and it's on the very front of your Earth Science reference tables. You can find it right here. So we're going to copy that down into our notes, and we're going to talk about the different things that we have here. The distance between the foci and the length of the major axis. We are going to talk about what those mean. So if we look at our elliptical orbit again, we'll see that there's the sun right here, and then there's another focus point right here. So the distance between the focus is just, we can measure the distance from here all the way over to here. Now, the distance of the major axis that we saw, so we can see here we have the major axis listed. So this is our major axis. The major axis is the length from here all the way over. So that distance from here to here is our major axis. And we can copy that formula into this spot in our notes right here. So the eccentricity is the distance between the foci, the length of that yellow highlighted line, divided by the length of the major axis, that light blue highlighted line. So you can try this out. You're going to want to grab a ruler if you don't have one. And we're going to look at the thing to the side here. And we're actually going to measure the eccentricity of this ellipse. So this thing right over here. And the first thing we're going to do is we're going to measure the distance between the foci. So that's this point and this point. Now when I do that, I get 0.56 inches. If you measure it in centimeters, you're going to get a different answer for this part, but you'll get the same one for the eccentricity actually. And for the length of the major axis, I'm going to measure from here to here. And when I do that, I get, so for that one, I got 1.7 inches. And when I plug that into this equation, I am going to get a number of around 0.33. So there's no units on that number, and that's just my eccentricity. So that's 0.33. And we'll notice that it was a number between 0 and 1. So the minimum our eccentricity can actually be is going to be 0. So the minimum eccentricity we can have is if there is no distance between the foci. So that's like a circle. Instead of having two foci, it's just got one. They're at the same point in the middle. The maximum eccentricity that something can have is if the distance between the foci is the same as the distance between as the distance along the major axis. So you'd, instead of having 0 divided by 5 and get 0, you'd have 5 divided by 5 and you would get 1. So our eccentricity is always going to be between 0 and 1. Now, one thing to bring up again is that we talked about these focal points when we were calculating the eccentricity, but for planets in elliptical orbits, it turns out that the sun is going to be at one of those points. So one of these focal points, like right there, that might be where the sun is. Now, where in the orbit along that path is the planet going to be going the fastest? Well, it's going to be going the fastest when it is right here, when it's closest to the sun, because gravity is going to be strongest right there. Sorry about that dead space there. We wanted to write the same as the edge of the Earth on that red line. Beyond that, you're going to want to be familiar with some of the classifications of the planets in our solar system. So Venus, Mercury, Earth, and Mars. They're both closer to the sun. They're smaller and they're rockier planets, and we call them terrestrial planets. Outside of the terrestrial planets, we have Jupiter, Saturn, Uranus, and Neptune. They're much larger. They tend to be made of gas instead of rocks. They're much farther from the sun.